Section 8.1.31. The data in a table to the right represent the ages of the winners of an award for the past 5 years. We're going to use this data to answer the questions from A through E. So the first thing we want to do is compute the population mean. So in order to compute the population mean, what we're going to do is we're going to add them all up and divide it by the amount that we have there. So we have 30 plus 42 plus 45 plus 30 plus 60, and we have 5 of them, so we're going to divide that by 5, and therefore the population mean is going to be 41.4. Okay, now we're going to, in part B, we're going to compute the mean for the combination with 5 numbers in the sample, but we're going to pick 2, and that's going to equal 10 samples with size n is equal to 2. So that means you see this 30 up here on the top left. We're going to combine that with the 42, with the 45, the 30, and then the 60. And then we're going to go to 42 and combine that with the 45, the 30, and the 60. And then we're going to go from 45 to 30 and 45 to 60, and then the 30 to 60. So let's go ahead and put those together. So we have 30 and 42, and then 30, and then 45, 30, and then 30, and then 30, and then 60. Okay, so now we're going to start with the 42. So now we're going to use 42 and 45. And then 42 and 30. And then 42 and 60. Okay, so now we're going to go from 45 to 30 and 45 to 60. So we got 45 and 30, 45 to 60, and then we have 30 to 60, and that's the last of them that we can combine as a sample size of 2. Okay, so what we want to do is we're going to take the mean of each sample is the sum of the two values divided by 2. So what we would do in the first one, and we can do this for the rest of them, but I'm going to show you how to do the first one. So you're going to take 30 and then add 42 and then divide that by 2, and that gives us 36. Okay, likewise, if we do that for 30 and 45, if we take 30 and then add 45 and then divide that by 2, and then that gives us 37.5. So I'm going to go ahead and fill in the rest. 30 divided by 30 plus 30 is 30. 60 divided by 2 is 30. 30 plus 60 is 90. Divided by 2 is 45. 42 plus 45. Divide that by 2 gives us 43.5. And then we get 36 here. 42 plus 60. Divide that by 2 gives us 51. 45 plus 30 divided by 2 gives us 37.5. And the next one we get 52.5. And then we get 45. So again, in order to get this part, what we did is we took 30, we added 42, and divided by 2, and that gave us 36. And you would do the same for the rest. Okay, so this gives us the samples and the sample mean. Okay, now, in part C, okay, what they want us to do is they want us to construct a sampling distribution for the mean by listing the sample means and their corresponding probabilities. Okay, so we want to list all the sample means in here. Okay, so let's take a look at the sample means. Okay, so what is the lowest sample mean? So we want to write this in ascending order from least to greatest. So if we take a look at the first sample mean, and we'll go ahead and highlight that. Okay, so 30 is the first one. So the first sample mean we have is 30. Okay, And then the next one is 36. We have one of them there and another one there. Okay, so let's write out the frequency. So we know that we have a 30 and the frequency represents one of them. Okay, and we saw that we had 36, which is the next one. And we had a frequency, we have two of them. Okay, the next number that we can look at is 37.5, and there's two of those. So we have 37.5, and there's two of those. Okay, the next number in a ascending order is 43.5, and there's only one of them. So we have 43.5, and there's one. Okay, and then the next number is 45. So there's 45, and there's 45, and there's two of them. So therefore there's 45, and we have two of those. And then we have 51, and there's one of those. So we have 55, and there's one of those. And the last one is 52.5. So we have 52.5, and we only have one of those. Okay. All right, so now what we're going to do is we want to now find the probability. Okay, now keep in mind here that there are 10 values. There's 10 samples, right? So if there's 10 samples, it's going to be the frequency divided by 10. So the probability for 30 is 1 divided by 10, which gives us a probability of 0.1. Okay, for 36, there were 2 out of 10, and that gives us a probability of 0.2. For 37.5, that is also 2 out of 10, which gives us 0.2. For 43.5, we had one of those out of 10, which is 0.1. For 45, we had 2 out of 10, which is equal to 0.2. And then for 51, we had 1 out of 10, which is equal to 0.1. And then for 52.5, we also had 1 out of 10, which is equal to 0.1. Okay, so now that we've done that, okay, now what we want to do is we want to compute the mean of the sampling distribution. Okay, so in order to compute the mean of the sampling distribution, we have to find the mean of all the sample means. Okay, so we want to find the mean of the sample means. So we have 130 in our frequency table. How many 36s do we have? We have 2 of them. How many 37.5s? We have 2 of those. Okay, and if you look here, we have 143.5. And then we have 2 45s. And then we have 51, one of those. And we have 1 of 52.5. Okay, so we know that we have 10 of those values, so we're going to divide that by 10. So if we divide that by 10, we get 41.4. Okay, so what is that telling us? Well, so far it's telling us that it matches what we have up here for the population mean and the sample, the mean of the sample means. Okay, so now what we want to do is we want to be able to compute the probability that the sample mean is within 4 years of the population mean age. Okay, so what is the population mean age? Well, we know that the population mean age that we found was 41.4. Okay, and what we want to do is we want to find values that are within 4 years of that. So what does that mean? That means that we want to take mu and we want to subtract 4, and we want to take mu and then add 4. Well, the population mean is 41.4, and we're going to subtract 4, and then we're going to take 41.4, and then we're going to add 4. Okay, so what happens? If we take 41.4 and subtract 4, that gives us 37.4. And if we take 41.4, that's going to give us 45.4. So what we want to do is we want to look at the sample means, and that's all of these here. Okay, so let me copy those. Okay, so what we want to do is we want to pick all the numbers that fall within these two values. Okay, so what does that mean? Well, if we look here, does 30 fall in there? No. Does 36? No. No. Does 37.5? Yes. Yes. Does 43.5? Yes. Does 45 fall in there? Yes. And then yes. And then 51? No. And 52.5? No. So what we determined here is that the three, numbers, or the values, so the values that we found that are within that range are the following: 37.5, 43.5, and 45. Okay, so now what we want to do is we want to go back up and find the probabilities for those. So what are the probabilities that we found there? Okay, so what is the probability for 37.5? Well, the probability for 37.5, is 0.2. So for 37.5, we know that we're going to add that to be 0.2. Plus, now what is the probability for 43.5? Okay, so we go to 43.5. The probability that we have there is 0.1. So that means we're going to add 0.1. Okay, and then what is the probability for 45 that we found? So coming back up here, here's 45, and the probability is 0.2. So that's plus 0.2. Now when we add them all together, that gives us 0.5. Okay, so that is the probability that the sample mean is within 37.4 and 45.4, or within 4 years of the population mean age. And so therefore, we can say that the probability that the sample mean is within 4 years of the population mean age is 0.5.